Hello friends, this is the fourth video on the limit of a function. In this video I will try to explain different theorems using inequality and especially the idea of sandwich theorem. First of all, let us consider a real subset D and f is a function from D to R. Suppose E is a limit point of the set D. If x lies between C and D for all x belongs to D and x not equals to A, in that case limit extends to A if x lies between same C and D. So if C less or equals to fx less or equals to D implies that C less or equals to limit fx less or equals to D. Suppose limit extends to A if x equals to capital N. Let sequence xn is a sequence of real number which converge to A. Then using sequential criteria we can conclude that the sequence f of xn must converge to capital N, capital L. So according to the given condition we have C less or equals to f of xn less or equals to D. Then C less or equals to capital L less or equals to D, because the sequence f of xn converges to capital L. So we have C less or equals to L less or equals to capital D. Hence the result is proved that C less or equals to limit extends to A f x less or equals to D. So this is the very first theorem using inequality. Now the second theorem is very interesting. This is known as squeeze or sandwich theorem. So why such peculiar name? We know that in a sandwich, two extreme ports, basically there are three layers. So two extreme ports are made of same components, especially bread. And in the middle part we use chicken or any raw materials. So two extreme layers are glued up with some raw materials at the middle position. So in this case, in the sandwich theorem, we have some real subset D and there are three functions f, g and h, or f, g and h, with some extra condition, that is fx less or equals to gx less or equals to hx. Then this theorem ensures that if the limits of two extreme functions are same, then the limit of middle function must be equal. That means if limit extends to A fx and limit extends to A hx are equal, then that equal limit is the limit of gx. So what's the proof? It is given that limit extends to A fx equals to capital N, capital L. So that means we have mod of fx minus L less than some epsilon for all 0 less than mod x minus L less than delta 1. Similarly, mod hx minus L less than epsilon for all 0 less than x minus L less than delta 2. So if we choose delta as the minimum of delta 1 and delta 2, then we have L minus epsilon less than fx less than L plus epsilon, and similarly L minus epsilon less than hx less than L plus epsilon for all x which satisfies the rule 0 less than mod x minus A less than delta, where delta is the minimum of those delta 1 and delta 2. Now we have to use the given condition, that is gx lies between fx and hx. So this is the middleman. Since L minus epsilon and L plus epsilon are two bounds for both fx and hx, so clearly those two bounds must be valid for gx also. So we have mod gx minus L less than epsilon for such delta. So clearly limit extends to a, gx must be same L. And finally we will solve few problems. For the first problem, we have to prove that limit extends to a x to the power 3 by 2 equals to 0 where x is positive. So we will use sandwich theorem. So how can we prove? Since x is positive, so for positive x, that means 0 less than x less or equals to 1, we know that this such relation holds, that is x less than x to the power half less or equals to 1. So if we multiply x, then we have x square less than x to the power 3 by 2 less or equals to x. Now this implies that limits of three functions must hold the same order. That means limit extends to x square should be less than limit extends to 0 x to the power 3 by 2 and should be less or equals to limit extends to 0 x. Now note one thing, limit extends to 0 x square is nothing but 0 and limit extends to 0 x is nothing but 0. So the limits of the extreme functions are 0. So clearly limit extends to 0 x to the power 3 by 2 must be 0 due to sandwich theorem, because x square is the function fx and x is the function hx. So limit of x square is 0 and limit of x is 0. So clearly using sandwich theorem, limit of x to the power 3 by 2 must be 0. Similarly, for the second problem, we have to show limit extends to 0 x sin 1 by x equals to 0. So in this case, we have to use squeeze theorem or sandwich theorem. We know that sin alpha or sin z for any real z lies between minus 1 and plus 1. Similarly, sin 1 by x must lie between minus 1 and plus 1. So if we multiply x in each place, then we will have minus x less or equals to x sin 1 by x less or equals to x. Now then we will have limit extends to 0 minus x less or equals to limit extends to 0 x sin 1 by x less or equals to limit extends to 0 x. Now limit extends to 0 x or limit extends to 0 minus x, that means limit extends to 0 mod x is 0. We know that as per our previous knowledge. So the limits of two extreme functions, that is limit of minus x and limit of plus x, are both 0. So clearly limit of x sin 1 by x must be 0 due to sandwich theorem. So these are very useful tools. That means sandwich theorem is very useful tool to find out a limit of any complicated function or any such thing. So these are few problems, and if you feel useful this video, then please like and share this video and please subscribe this channel, and we will come back soon with more useful videos on continuity, differentiability and such things. Thanks a lot.